Now, there are several different kinds of compounds. You may think that all compounds are made of molecules from what we've said so far, but there is an important class of compounds that are not made of molecules, but made of separate ions, positive and negative ions. Some vocabulary. Cations are positive ions. Anions are negative ions. And what sticks the compound together is the attraction between a positive charge and a negative charge. Now, you get some elements that have got very low ionization energies, so they form cations very easily. And you get some other elements that have very high electron affinities, and they want to grab electrons from other things so that they form anions easily. So the things with lowest ionization energy on the periodic table are all over on this side of the table. Now, here's the boundary line between metals and nonmetals. If you're on this side of the boundary, you've got a metal. If you're on this side of the boundary, you've got a nonmetal. If you're on this side of the boundary, you have elements with relatively low ionization energies. They form positive ions, everything over here. And if you're on this side of the boundary line, you've got nonmetals with high electron affinities. They release a lot of energy when they grab an extra electron. They want to be like the nearest noble gas, so they're going to grab electrons from anywhere that they can and form negative ions. Positive ions, cations, negative ions, anions. So you usually see ionic compounds forming between metals and nonmetals. Let's look at how an ionic compound would form between sodium and chlorine. Here I have a sodium atom and a chlorine atom. This one, if I look at it where it is on the periodic table, it wants to gain an additional electron to get an argon configuration. So it wants to gain an electron. This one wants to lose an electron, and if it lost one electron, it would have a neon configuration. So what's going to happen to these two atoms when they come together is that the sodium is going to lose an electron, and the chlorine is going to grab that electron. So in the first process, you've got a loss of electrons. That usually happens to a metal. Metals lose electrons in reactions like this. And you've got a nonmetal that is gaining electrons. And then there's a third step where the sodium ion that's formed and the chloride ion that's formed. This is called a chloride ion. We'll talk about why it's named a chloride ion and not a chlorine atom later. But this is the positive ion, the cation, and this is the anion, the negative ion. And they can come together, and when they do, they'll come together like this, but others can start packing around them. And pretty soon you get a regular array of ions here. And you keep packing them on here. And you can make a crystal structure out of this. So there are no molecules when this compound forms. You have instead what's called a lattice of ions. Now let's look back up at this. Here you've got this loss of electrons process. This is called an oxidation. So here's a vocabulary word. Whenever you have an element or anything losing electrons, you can say it's undergoing an oxidation. Or you can say it's getting oxidized. So you can say here sodium gets oxidized. And usually you'll see if something is getting oxidized, you'll always see a more positive charge. The charge will rise. It will get more positive. Now here you don't see that. The charge on the chlorine goes from 0 to -1. So the charge is going down. The charge is being reduced. We can say that the chlorine gets reduced. And they'll call this little half of the reaction the reduction. And you can couple these two together. If you add this to this, you're going to see there's an electron popping out over here on the right-hand side, and there's an electron being consumed on the left-hand side. So when you add these up, you will get sodium plus chlorine gives you Na plus Cl minus, because we had this electron transfer between them. So the electron popped off the sodium and went on to the chlorine. This is an electron transfer reaction. And we can call it also known as a redox reaction, or an oxidation reduction reaction. So these are synonyms: electron transfer reaction, redox reaction, oxidation reduction reaction. Those are just 3 different ways to describe this same reaction. You know, any of those is okay. Now something else happens. The ions are going to come together and make that lattice. And now I have the compound. Now when I push these two together, their charges neutralize. So I don't write the charges in anymore when I set them into the same formula. We're going to see later this is called sodium chloride. It's table salt. Now let's do another one like that. Suppose I want to put together a calcium and a fluorine. Is that going to work? Well, let's think about how many electrons each of these wants to lose or gain. Let's look at calcium. Calcium is here on the table. It wants to get to the nearest noble gas, which is argon. So it's going to, let me focus this a little. It's going to lose 2 electrons to get to be argon. So it's going to form a calcium ion with a +2 charge. So I can write calcium is going to want to lose 2 electrons. What about fluorine? Fluorine is sitting next to neon. It wants to be like neon, so it's going to gain an electron to be like neon. So fluorine will grab an electron excuse me, and become a fluoride ion. Now, when I try to add these together, I'm going to have a problem, right? Because I have 2 electrons being spit out by the calcium, but the fluorine is only taking 1. So what I'm going to have to do is add another fluorine to grab the other electron. This gives out 2. I have to grab the same number that are being spit out by the calcium here. So what I can do is double this reaction up. And if I add these together, I can see that the 2 electrons on the right are going to cancel out with the 2 electrons on the left. And I am going to get a reaction that looks like this. Calcium plus 2 fluorines is going to give me a calcium ion plus 2 fluoride ions with a -1 charge. And then I'm going to put those together like I did up here. When these come together, they're going to neutralize each other. I've got 1 calcium and 2 fluorines. So that will be the compound formula. Here is the oxidation. It involves loss. And here is the reduction. It involves gain. You can keep them straight. Which one of these is the oxidation and the reduction? Oxidation involves loss of electrons. Reduction involves gain of electrons. So there's a mnemonic, a little memory trick that you can use to keep straight which one of these is an oxidation and which one is a reduction. Let's try one more. Suppose I bring together aluminum and sulfur, and I want to form an ionic compound from them. Well, I have my metal and I have my nonmetal. My metal is going to be losing electrons. Let's take a look at where aluminum is. Here's aluminum. The nearest noble gas is going to be neon. And it's going to lose 1, 2, 3 electrons to be at neon. So what I'm going to have is the aluminum is going to turn into aluminum with a +3 charge, so it can give up those 3 electrons. That's the oxidation because it's losing electrons. Now let's look at the sulfur. What does it want to do? Sulfur is sitting near argon. It wants to pick up 1, 2 electrons to be like argon. And when it picks up 2 electrons, it's going to have a -2 charge. Okay, we got a problem here because I got 3 electrons being given up and 2 electrons being consumed. And I've got to put these together in a way that is going to cancel out the number of electrons that are there. Now think about this for a minute. These are equations, really, so you can multiply both sides by a constant and the equation still works. We did that with the fluoride equation, the F to F minus equation. We multiplied it by 2 to get things to work out. What can we multiply these equations by to get the electrons to cancel out? Well, if I multiply the top one by 2, I'm going to get and if I multiply the bottom one by 3, I'm going to get, whoops, I forgot the electrons. Now this is better. I mean, why did I pick 2 and 3 for this? Do you see why? I needed to get the same number here as here. And if I take 2 times 3, that's 6, and 3 times 2, that's 6. So that's going to work out. All right. So what I'm going to get is an overall equation when I add these up that looks like 2 aluminums plus 3 sulfurs is going to come together to give me 2 aluminum ions with a +3 charge plus 3 sulfide ions with a -2 charge. Now notice that these then can come together and make a compound. I have a total +6 charge here, 2 times +3, and I have a total -6 charge here, 3 times -2. So when I bring them together, I'm going to get Al2, because there's 2 of these, S3. That's the formula for aluminum sulfide. Now there's a trick that you can use to work this out a little bit more quickly than I did here. And it is like this. If you want to bring together a +3 ion and a -2 ion, you can try swapping the charges as subscripts. If I take the 3 and put it on the S, let's see, here's Al in the formula and here's the S. So if I take the 3 and I put it there, and I take the 2 and I put it there, that'll work. I'll get Al2S3. That's a quick and dirty rule that you can use. Swap the charges as subscripts to get the formula of the ionic compound that comes from this. We're going to be practicing this a lot more in later videos, especially the ones where we're learning to name ionic compounds.